Can artificial intelligence and quantum computers really prove that our reality doesn't exist? Imagine waking up one day and finding out that everything you know might just be an illusion. This isn't science fiction. It's a theory that a group of physicists is seriously investigating. They propose using AI and the bizarre principles of quantum mechanics to challenge our very understanding of existence. Sounds wild, right? Let's dive into this mind-bending concept and explore how AI might reveal the true nature of our reality, or the lack thereof. AI and quantum computers, challenging reality. A group of physicists is aiming to use artificial intelligence to prove that reality doesn't exist. As bizarre as it sounds, it's not a joke. They plan to combine AI with quantum computers, making the theory even more intriguing and controversial. This concept is complex, so let's start from the basics, or maybe the end. It's hard to say in a reality that might not even exist. In quantum mechanics, the outcome of a measurement is not predetermined. The theory makes probabilistic predictions, and only when a measurement is made does the outcome have a specific value. The measurement problem, which is central to this idea, arises because quantum mechanics doesn't define what constitutes a measurement. Most physicists agree that we lack a precise definition of a measurement, but we understand it as an interaction with a device called a detector. Detectors make measurements, even if we can't formally define them. However, a significant number of physicists believe a measurement is not a physical process, the idea behind the theory. 2 years ago, a groundbreaking paper shook the foundations of physics by suggesting that reality might not exist as we perceive it. This provocative idea challenges our intuitive understanding of the universe. In the realm of quantum mechanics, where particles can exist in multiple states simultaneously until observed, the concept of reality becomes elusive. Quantum mechanics, a cornerstone of modern physics, predicts outcomes probabilistically rather than definitively. The crux of the issue lies in the measurement problem, defining what constitutes a measurement. While physicists agree that measurements involve interactions with detectors, the nature of these interactions remains undefined. Enter Eugene Wigner's thought experiment, Wigner's friend, which illustrates the complexities. Imagine a friend in a lab observing a quantum particle. Before measurement, the particle exists in a superposition, simultaneously in multiple states. Once measured, it collapses into a single state. The interpretation of when and how this collapse occurs sparks intense debate among physicists. In 2016, the thought experiment expanded to include entangled particles in separate labs, complicating the scenario further. By 2018, Kaslow-Bruckner's work suggested that if observers could exist in superpositions, their differing perspectives could imply reality's dependency on the observer, a concept unsettling to our classical understanding. These discussions culminated in 2019 with experimental tests involving photons, probing the theoretical implications with tangible results. Now, researchers propose integrating artificial intelligence into quantum experiments, positing that AI on quantum computers could exist in superpositions akin to human observers. However, practical challenges, like developing human-level AI and sufficiently powerful quantum computers, underscore the speculative nature of these proposals. Wigner's friend thought experiment. Let's delve deeper into physicist Eugene Wigner's intriguing thought experiment, famously known as Wigner's friend. Picture this. Wigner's friend is in a laboratory observing a quantum particle that has the peculiar ability to appear either on the left or right side of a screen. Before any measurement takes place, the particle exists in a mind-boggling superposition, simultaneously existing in both left and right states. It's only when a measurement occurs that the particle's position becomes definite, appearing either on the left or right side of the screen. The twist in this scenario lies in how we define a measurement. According to quantum mechanics, the act of measurement itself is not clearly defined. This ambiguity has sparked decades of debate among physicists. In 2016, the thought experiment was expanded by proposing a scenario involving two individuals in separate laboratories, each observing entangled particles. This extension added layers of complexity to the original idea. In 2018, physicist Kaslov Bruckner took this thought experiment further by demonstrating that if these individuals could indeed exist in superpositions, a theoretical impossibility, their observations would fundamentally contradict each other. This revelation sparked headlines suggesting that reality itself might not be independent of the observer's location or interactions, pushing the boundaries of what we understand as reality. Experimenting with photons. In 2019, researchers from Edinburgh embarked on an intriguing experiment based on the extended Wigner's friend scenario. Instead of using people, they utilized photons, particles of light, as their subjects. While photons differ vastly from humans, the essence of the experiment remained to explore the ramifications of quantum mechanics on the nature of reality. Photons were chosen due to their unique quantum properties, such as being able to exist in superpositions, multiple states simultaneously, until observed. The experiment aimed to demonstrate how these quantum properties could extend the boundaries of our understanding of measurement and reality. The setup involved entangling photons in separate labs, mimicking the entangled particles in the Wigner's friend thought experiment. By observing how measurements and observations affected these entangled photons, researchers hope to shed light on whether the act of observation itself influences reality. While photons don't possess consciousness or decision-making abilities, their behavior in these experiments could provide clues about fundamental aspects of quantum mechanics and our perception of reality. Introducing AI into the equation. The latest development in this quest to challenge reality involves integrating artificial intelligence into quantum experiments. Researchers propose placing human-level AI on quantum computers to act as observers in complex experiments. The idea is to leverage AI's potential to interact with quantum states and perform measurements in ways that might reveal new insights into quantum phenomena. AI, with its ability to process vast amounts of data and make decisions based on complex algorithms, could potentially replicate human observation in quantum experiments. This approach aims to explore whether AI's involvement can affect quantum states similarly to human observation or introduce entirely new dynamics into the measurement problem. However, significant challenges remain. Current AI lacks the sophistication to match human-level intelligence required for these experiments. Additionally, quantum computers capable of supporting such AI operations are still in early developmental stages. Despite these hurdles, the idea underscores the growing interest in exploring unconventional avenues to tackle long-standing mysteries in physics. The importance of testing quantum systems. Central to these experiments is the critical need to test and understand large-scale quantum systems. Quantum mechanics predicts behavior at microscopic scales but becomes increasingly complex as systems grow larger. Testing these systems rigorously can elucidate which configurations uphold quantum principles, like superposition and entanglement. Identifying and controlling these configurations could potentially resolve the measurement problem, a fundamental challenge in quantum mechanics. By pushing the boundaries of quantum experimentation, researchers aim to refine our understanding of how quantum phenomena interact with the macroscopic world, and perhaps even redefine our conception of reality itself. These experiments not only push the limits of scientific inquiry, but also invite philosophical contemplation about the nature of existence and our role as observers in a quantum universe. Can you have an existential crisis if reality doesn't exist? Share your thoughts in the comments, and don't forget to hit that like button and subscribe to our channel for more amazing content. Thanks for watching, and we will see you tomorrow.